Chapter 4. This chapter deals exclusively, primarily, with databases and data warehouses, and again contains some introductory kind of overview of what the systems are that we have in business to be able to store all this vast amounts of data and be able to retrieve that when we need it for our business decisions. So let's go over some of the concepts and some basic terminology. One of the key things with anytime you're dealing with data is what's the quality of that data? Can you rely on it? So some of the attributes, is it accurate? Certainly it needs to be accurate, but what is the definition of that accuracy? Is it 1 decimal place, 5 decimal places? Depends on what the information is. If you're doing complex modeling like weather programs, then when they model future weather outcomes, you may have to be accurate to 100 decimal points. But so it's making sure that the data you do have is accurate. And that really plays into also the idea of the precision. Just how precise does it have to be? And do you have everything that you need? Is the data complete? Do you have all of last year's data points, or are you missing the months of August and July? So making sure that you have whatever for particular information, what defines that completeness? How thorough does it have to be, or can it be weekly? And then is it consistent? How was the data gathered? How was it recorded? It's I guess the first thing that comes to mind is outside of the US, the format for the date is different than in the US. In terms of month, day, and year, which of those comes in which order. And so are you consistent with your date information? Timeliness. It's great to have a bunch of data, but if it takes 6 months for the data to be processed before you have access to it, it's not as helpful as if it could be available in 6 minutes. The one that comes to my mind is the government jobs report that they come out with. It's nice to know that they've come out with a revised jobs report as to what happened in 2024. But we're almost through 2025. How does that help me in terms of what I'm thinking about the economy and everything else? It would be much nicer to have almost a real-time jobs report that was accurate. Of course, that's been one of the problems with the numbers recently. If you've been following the news, there were a number of months where the government had to revise the jobs report significantly. Their estimates were not even close. Now, an interesting thing talking about data is this idea of bias. You want to have just the facts. You want to make sure that you haven't had any bias affect what was put in there. I'll give you an example from when I worked at Precision Interconnect. We did life testing of our products. And I was talking to the quality engineer about a new product we were testing and seeing how it was going. And they mentioned that they had had some early failures and they discounted those. They just excluded them from the quality report because it said, well, that was obviously an outlier. And so we just ignored it. That engineer was bringing in a bias. He knew that our products, quote unquote, knew that our products would last longer than that. So the fact that it failed early, well, obviously something was wrong with the test and left the data out. I had some interesting discussion with him as I discussed, and pointed out, no, that's a valid data point. That tells us something. You cannot discard data just because it doesn't fit what you were expecting. We really need to look at that and see what caused that early failure. Was it really just a fluke, an outlier? And yes, you do get those. Or was it showing us something that we hadn't realized before, that we had built in with this new product, an inherent weakness? So it's important to make sure that the data and the information you have, that those outliers have not been excluded unless you have spent the time analyzing and you come up with a valid reason why you can disregard those. And then another key thing with this, when we're talking about data and information, duplication. You really want to have only one source for a particular piece of information. You don't want to have duplicate places that you can go and find the same information. The problem is that those duplicate locations get out of sync with each other. Data gets updated in one area, but it doesn't get updated in another. This happens a lot when you're looking at things like addresses. Purchasing may have updated an address for a vendor, but accounting didn't get the news that that address had changed, and so they have the old address for that. That's a problem, and we'll talk a minute about how do we keep that from happening. So one of the things you will run across a lot is this idea of tables. You'll hear people talking about tables. And a table is really just, think of like what's shown here. The author has this simple diagram. It's like on an Excel spreadsheet where you've just got some information. You got columns and rows, and that's a quote unquote table. Now, the terms you'll hear, the first is a field, or another way of thinking of anytime you hear field, that's an attribute. That's something about somebody or something. And so, for example, with this, there's a number of attributes, but let's just look. Breed. Breed is the attribute of that particular dog or cat. And so that's a field. Breed would be a field. A record is just all the fields that you have that pertain to a particular unique individual or unique entry. So for example, in this case, the pet ID 201449, that's a record. What's highlighted there, that's all the information we have about that particular. Now, key concept here is that pet ID is a unique field. It's a key. In any time you're talking about databases, you have to have identified what are the unique keys that point to only one set of data, not to multiple sets of data, so that you can find exactly what you want. And that's especially true when you're designing databases. I'll talk a little bit more about that in a minute. And then the table, as I said at the start, is just this collection of all the records. Now, for a veterinarian's office, there would obviously be a lot more rows and probably a lot more columns. Things like vaccination, was the animal spayed, last visit, any number of things that could be added in there as fields. And then, of course, a veterinarian wouldn't stay in business if they only had 4 animals in their client base. So as I mentioned, the problem with data is having it be accurate and up to date and everyone using the same source of data. The term that's used for that, one of the tools that businesses use, is called master data management. And I've included a supplemental video. If you go into the course content section for this week, you'll see there's a page there that has supplemental videos. And there's a video in there. It's a pretty good video, very simplistic, goes through the concepts of what is master data management. So I encourage you to watch that in addition to the explanation that the author has provided in the textbook. So let's talk a little bit more about database architecture. We kind of talked, fields and records, but then you'll hear them talk about, well, what's the relationship type in the database architecture? And so the first concept is one-to-one. And what's meant here is that an employee has only one birth date. So there's one-to-one. There's only one value associated with it. Now, I would say that this isn't probably the best example, because if you go the other way around and say employee birth dates, there can be multiple employees that have the same birth date. So perhaps a better example would be an employee ID to their social security number. There's going left to right or right to left. It is strictly, there is only one. They are uniquely tied to each other. Now, the next you'll hear talked about is called one-to-many. And so in this case, that employee ID, you see there, 555, they have several dependents. There's 3 of them there. So one employee ID, multiple dependent names. So that's one-to-many or one-to-multiple. And then the last is many-to-many. And this is where employee 555, and they are working on several projects. Looks like they're working on project 10 and 11. And doesn't look like anyone else is working on project 10. So, but you go to project 11 and there are multiple people working on that. So the employees are working on multiple projects, and projects have multiple employees working for them. So that's the concept of many-to-many. This becomes important only if you're designing the database. You have to understand the relationship. It determines how you set up, what are the key fields, what are the tables you create. So you'll hear it talked about, but again, unless you are one of the people involved in designing a new database, you'll never personally have to use it. So as I mentioned, the database is really just a bunch of tables of those records. And with a relational database, what you do is you have all these smaller tables that are much more manageable, and they are linked to each other via fields that are called keys, and those keys are unique so that you can combine a dozen different tables together, link them together through these key fields, and be able to get a lot of data instead of having a table that has 40 columns. You may have 20 tables that each have 4 or 5 columns, but the relationship that's defined with them allows you to piece them all back together, I guess. But it's a lot easier to maintain smaller tables than it is massive tables. But as I mentioned, those keys that provide that linking have to be a unique key, something that does not match with anything else. The PCC student ID number is a unique key. There's only one student assigned to that key. Your social security number is unique. There are a number of things like that with our veterinarian. I think it was the pet ID number. But you do have to have those key fields that are unique that link to one another. Normalization, you'll hear that talked about, is this idea that when you build the structure of the database, we're not going to have repetitive information in any of the tables. So by using normalization, you can break it up into smaller tables where you have everything is unique. And so it's just the process of eliminating it. And the reason for doing that is if you have the same data, the same piece of information located on more than one table, there's always the possibility of one getting updated without the other one. So normalization is that process by which you really eliminate those opportunities for things to get out of sync with each other. So an example here, there's two tables. Now, again, like I said, you might have 10, 15, 20 different tables in your particular application. But the thing that is unique with both of these tables that are shown here is the student ID field. So by using that and having them linked together with these fields, we can make sure that when you assemble all the information about student 54001, there's no duplications. Everything is unique, so you don't have that problem of things getting out of sync with each other. Again, terms that you'll hear talked about: distributed databases and relational databases. There's a couple of great videos, again, in the supplemental videos that go over what do we mean when we say a distributed database and what is a relational database, as opposed to, early days, they had what were called flat files or flat databases. So I encourage you to watch those videos. They do a pretty good job, I think. And again, that's to supplement what the author has already written. It's great to have this big, massive amount of data, and you probably have some built-in, if you're a company, whatever, some reports that are normally run all the time. But what happens when you want to get a custom report? Now, it used to be what you would do is you would submit a request to IT, and they would go out and write a bunch of computer code to get back the information that you wanted, and that might take days or weeks to be able to get that. But then it came up with this way of accessing the database using structured query language, SQL. And the nice thing about SQL is that anybody can use it. So any manager can write their own specific query to get the exact data in the way they want to see it. You don't have to do any complex coding. It's very similar to written language. So you have verbs and nouns and objects. There's some definitions. You have to follow the syntax and do it correctly, but you don't have to use any of these complex coding terms, that if any of you have taken any programming classes, this is very simple language, much easier to use. And again, I've provided a supplemental video in this week's course content that goes over and gives you some examples of SQL and how, what are the commands that you would use to create a database, what are the commands you would use to extract information from the database or to load information into the database, how do you change something that's there. It's really quite simple and easy to use. Now, managing the database, one of the key things the author mentions is this idea of performance tuning and scalability. And with performance tuning, that's really, how quickly can you get the data you're after? Over time, a database can get slower and slower in retrieving it. So it's this idea of periodically going through and making sure everything is tuned up so you're getting the maximum efficiency in retrieving that information. The concept of scalability is, can we add more to the database? Can we add additional fields? Can we import in additional information from elsewhere so that it can be scaled into a much larger database? Now, the key with all of that is your ability to do that, both to optimize the performance and also add more capability, is that your database has to have been designed to allow that. When I was at Leviton, there was someone who had created an SQL database that did not understand the basics of database design. And so it was just a nightmare of tables that were linked in crazy different ways. And you almost always, when you ran a report, you would get duplicate data in there. So I would have to, anytime I got the report, I would have to then run an Excel macro to go in and clean up everything. And it was all because it was not designed properly. So thinking about these things when you're involved on the front end, if you ever are, it's really important, because at the beginning, before you have a bunch of information in there, you can make changes very easily. But once you have an established thing, it can be very difficult, time consuming, and hence expensive to make fundamental structural changes. I like that the author brought up this idea too. With the database, there's integrity. We need to know that the information there is legitimate. And so with that also, though, comes security. There's probably some proprietary information in there that we would not want our competition getting. And so we need to think about, how do we protect it? And that, I'm sure, it would, one of the things that would involve would be limited access. You control who can get at that secure information and where they can access it. Can it only be accessed from a specific terminal or in a specific location? And then also, what's your disaster recovery plan? What happens when your server, if you have data stored locally at your company, if you have a fire and that gets destroyed, or if you're hosting it in the cloud, the company that you've hosted it with goes out of business? What do you do when you need to recover information? For example, and this is an example, they had a recovery plan in place, but it wasn't quite good enough. I did some consulting work for a church and helped them establish a new website that included the members of the church, all their information, and a variety of different things. And it was hosted by a company, and this company did the right thing. They had the data for the website, was stored not in a single location, but in 4 separate locations around the United States in different areas of the country, so that any single event, like an ice storm or a power outage or an earthquake, a single event, it would be extremely unlikely to knock out all 4 of those locations, because it's somewhere on the West Coast, the East Coast, in the central area, in the South. It looked like a good plan. The one thing they hadn't thought about, though, is a disgruntled employee. One of their IT programmers, the company, they had decided they needed to let go and to fire. This employee knew that they were on thin ice, so to speak, and thought that they might get fired. So they had created some code. So all they had to do is push the button when they walked out the door, and it would erase all the data at all 4 locations. And that's exactly what they did. Now, there's obviously that individual broke some laws, and the federal government, the FBI, got involved in going after them and prosecuting that individual. But all the data was gone. There was no recovery. And in fact, our website was down for a couple of weeks. What they had to do was use tools like, which it's kind of a funny or fun tool if you haven't used it. It's called the Wayback Machine. And this organization started many years ago, and they just go out and periodically, they just randomly go to websites and download all the information from the website at that time. So you have a snapshot. So you can go and see, okay, what did Microsoft's website look like in 2002 or whatever, something like that. But they were able to use tools like that where there had been snapshots taken of existing websites, and they had a team of programmers that were recreating all of the websites that this disgruntled employee had destroyed. So recovery is a very important thing because things do go wrong. But probably the biggest one that I see lacking in a lot of times is documentation. So in the beginning, when the database was created, the team that created it really needs to document what they did and why, so that someone 5 years later coming in that wasn't part of the initial thing, they need to make a change, well, they can go to the documentation and relatively easily figure it out. This is true in any of the IT tools and so forth that we talk about this term. Website design, any, when we talk in a later chapter about dashboards, just how this was all designed needs to be documented so that someone else coming in to make a change can relatively easily do it. For example, when I was a webmaster, I inherited a website where in the code for the website, there was not one single comment. And that's something you can easily do when you're creating a website design within the HTML code. You can put comments in. And it was several thousand lines of HTML. And so when I had to make changes or fix issues that occurred, it was very time consuming and frustrating because I first had to figure out the logic that they used in creating that code and then find out where they went wrong in creating it. So documentation, very, very, very important. The author included a couple of case studies, which we're actually not doing either of these for this term in this class. They're interesting. I may use them next term. Think about it. One is the UK police case. And the interesting thing with video surveillance, the United Kingdom, of all the countries in the world, probably has the highest density of video cameras of any country. And we'll actually talk about them in a later chapter when we're talking about privacy and cybercrime. But the tools have gotten so advanced with databases that they can take a video. It could be a patrol car driving down the street and they have a camera and it's scanning vehicles parked along the side, like this is showing here, where they're recognizing that license plate number, run it through the database and immediately determine, has that been flagged? Is there something about that vehicle that needs to be looked at further. Raises a whole bunch of privacy issues, and there, like I say, I've got a video that we'll go over in a later chapter where we look at some of the concerns that having this massive database, but the processing power is available now to where this can happen real time. Now, another interesting thing about in this chapter is the concept of blockchains. And you go, what does a blockchain have to do with a database? And as the author goes through with distributed database architectures, blockchains can be a very useful tool. Now, of course, the obvious example of a distributed database is when we put stuff out on the cloud, we have stuff distributed wherever by the servers, and that's all put out there. But the really interesting thing is using blockchain, we can ensure the integrity of that information, those bits of data that have been spread out all over the place in the cloud. And people normally think when you talk about blockchain, they think about cryptocurrencies. And while cryptocurrencies were perhaps the first industry to take advantage of blockchain, very quickly other companies have recognized that it can be used in normal business. It's not limited to crypto. And in particular, Walmart is the one that really comes to mind, where they recognized how they could use blockchains to ensure integrity in their supply chain, the source of origin for the products, and even do things like for product recall for safety issues, that using blockchains could give them a much better control over their business. And I do have a supplemental video. Again, this week, we've got several videos that I'm encouraging you to watch that goes over specifically how blockchains can be used in the supply chain. And so, as I mentioned, the author has a Walmart blockchain case. You might read over it. It's interesting information. And so you can see how Walmart is using that to track their shipments and how they could use that to minimize this risk to the public with foodborne illnesses and being able to deal with that. So that's chapter 4. You know, going through as you read it, you may find a bunch of technical terms and other things that mainly you need to be aware of, just be familiar with them. But the key concepts, I think that's what I wanted to hit in this week's lecture.